So class, today we are going to cover annuities. What is annuity? It is a series of equal payments at a fixed intervals for a specified number of periods. In this definition, we have four important things. First of all, there should be a series of payment. Means this includes more than one payment. Second is it is an equal amount payments, means each payment is equal. Like if one payment is for $100, then the second payment should also be $100. The third payment is also $100. The third important thing is fixed interval, means the time period between two payments should be equal. Means if we have a 1 year difference in one payment, then there should be another 1 year difference in the second payment, and in the third payment there is also 1 year difference. So the interval should be fixed or same for each payment. The last thing is that the payment should be for a specified number of periods. Means the payment should have some fixed number of period, like it should be for 5 years or for 10 years or for 6 years or for 20 years. Okay, so this is annuity. We have two different type of annuities. One is ordinary annuity and the second is annuity due. An annuity whose payments occur at the end of each period. At the end of each period means when you do payments at the end of the period, that is after completing one time period, then this is ordinary annuity, or you can say deferred annuity. Annuity due is one in which payments occur at the beginning of the time periods. Means here you can see that the payment is from the very start, that is from the start of the year one. And here in annuity ordinary, the payment is at the end of the after completing 1 year or one time period. So we have two type of annuity, ordinary or the due annuity. Here these are different formulas which can help to calculate present value or the future value. Future value of annuity is equal to payment PMT times 1 plus interest raised to power n represent time period, the number of periods, minus n divided by interest. And the present value of annuity is equal to PMT 1 minus 1 divided by 1 plus interest raised to power n divided by interest. So these are the two definitions of two formulas of future value of annuity or present value of annuity in case of ordinary annuity. If we would like to calculate annuity due, then simply we just have to multiply ordinary annuity by 1 plus I, 1 plus interest. Same is the case with present value of annuity due is equal to present value annuity multiplied by 1 plus I. So first of all, you will have to calculate the future value or the present value of ordinary annuity. Then if you want to calculate annuity due, then simply multiply the answer of ordinary by 1 plus I. These are some problems which we are going to solve. These are related to future value and present value of annuity, both the ordinary and the due. 5-6. What's the future value of a 7% 5-year ordinary annuity that pays $300 each year? If this was an annuity due, what would its future value be? So in this problem, future value is required at of a 7%. What is 7%? This is interest. This is number of period, that is 5 years. That pays $300 each year. Each year means each year represent series of payment. Means $300 5 times each year. Okay, so means $300 have total 5 payments. If this was an annuity due, means you will have to calculate both the ordinary annuity and the due annuity. So here's the Excel sheet. We have given data. We have interest is given I 7%, or you can say 0.07. Time period is 5 years. PMT, or the payment, $300 each year. So this is the formula to calculate future value of ordinary annuity. Future value of annuity is equal to payment multiply factor. The factor is 1 plus interest rate is 0.07, and the time period is 5 years minus 1 and divide by interest rate. So this is the way to calculate factor, present value factor. So PMT multiply by factor. Here we are going to calculate the factor. PMT is, we have 300. Okay. So here we have again 300 is equal to 300 multiplied by factor. We have just calculated the factor. So the answer is $1,725. This is the future value of annuity. And how you can calculate annuity due? We have, what is the formula? Future value of annuity due is equal to, we have future value of annuity ordinary, and it should be multiplied by 1 plus I, that is interest rate. Okay, so future value of ordinary annuity we have just calculated. Here it is this one. Okay, so is equal to 1725.22 multiplied by 1, and the interest rate is 7%. So this is the answer. This one, $1,845, 45.9799 is the answer. Okay, class. So the next is 5-14, future value of an annuity. Find the future values of these ordinary annuities. Compounding occurs once in a year. So the A part is $400 per year for 10 years at 10%. B, $200 per year for 5 years at 5%. C, $400 per year for 5 years at 0%. And the D requirement is rework part A, B, C, assuming they are annuity due. So what we will have to do is to calculate annuity ordinaries as well as annuities dues. So in part A, okay, future value of annuity is equal to payment. We had 400 in payment, multiply by factor. So present value factor, we have 1 plus 1 plus interest rate was 10% in requirement 1, and the time period was also 10. Okay, then minus 1 from the formula and divide by interest rate. So in the next step, 500 multiplied by factor. What is the amount of factor? Here it is, 15.937. So the future value of annuity should be 400 multiplied by factor. So the answer is 6,374. If you invest $400 per year for 10 years at the rate of 10%, then you will get 6,374. In requirement B, same procedure, just amounts are same. Change 200 multiply 200 multiply by factor, that is 1 plus, now the interest rate is 5% and the time period is also 5 years, minus 1 from the formula and divide by interest rate. So 200 annuity, 200 is the payment and the factor is 5.525, and then the last step, just multiply payment with factor. So the amount is $1,105. The last part is C part, where we have to calculate future value and we have 400 payment. But you know, the interest rate is 0. If the interest rate is 0, then we don't need to use this formula. We have payment and we have total time period is 5 years. So we have 5 payments. So simply 4,000 is the payment for 5 years. So the answer would be 2,000 is the future value, because here we don't have any interest. So whatever we invest right now we get the same amount in the future. The next requirement D, is to calculate annuity dues. So future value of annuity due is equal to, we already calculated future value of ordinary annuity. So we simply multiply this answer by 1 plus I. Means we already have this future value of ordinary. Okay. So future value we have 6374.97, and it should be multiplied by 1 plus interest rate. Here the amount is 7,012. Okay, so we use the same procedure for next part. We already have calculated ordinary annuity. So with the help of ordinary annuity, we can calculate annuity due just by multiplying 1 plus interest. The same cases with part C. Okay, class. So this was 5-14. The next topic, the next problem is 5-15. Here you can see the data is same as given in 5-14, but the only thing is here you will have to calculate present value. Here it was for future value. Rest of the data is same. That is PMT is 400, 200 and 400 in part A, B, C respectively. Then we have 10 years at the rate 10%, 5 years at the rate 5%, 5 year at the rate 0%, and the annuities due. You will have to calculate ordinary as well as due. Okay. So here is the Excel sheet and 5-5. So this is the formula of present value. Part A, present value of annuity is equal to, we have same $400 PMT. It should be multiplied by factor, and the factor is 1 minus, okay, 1 divided by 1 plus interest, and we have 10% interest, so 0.1, and we have 10 years, so multiply by 10, then divide by 10%. Okay, so in the next step we have 400 and the factor is how much factor? It should be, there's some typo error. Let me check it first. A bracket was missing. Okay, class. So next step is to calculate factor. And the factor is 6.1445. And then the last step, simply multiply your payment with the factor. So this is the present value, $2,457. Same is the part B. Present value of annuity is equal to, now this time we have 200 as PMT and multiply by the factor. This is the formula of factor. Here the interest rate is 5% and the time period is also 5. So interest rate is 5%. Okay. In the next step, simply multiply PMT with the factor. So the answer is multiply by 200 multiplied by factor. This is the answer, 865. And the last step where we have 0% interest rate. So when we have 0% interest rate, then we don't need any formula. Simply multiply your payments, which are 400, with your time period, that is 5 years. So multiply 400 with 5 years, you get 2000. So 2000 is your present value. Okay. Now the next part, D part. In D part, you have to convert all ordinary annuities with the annuity due. So first of all, here in part A, we have this value. So we are going to convert this annuity into due. Present value of annuity due is equal to ordinary annuity. What is the value of ordinary annuity? 2457 multiplied by 83. 2457.83 multiplied by 1 plus interest rate is 0. Interest rate is 10%. Okay. So here we are going to calculate it this one. Okay. Similarly, you can do other parts as well. So here is the answer. Okay, class. Now, the last topic for today's class. The last topic is when we have uneven cash flows. Uneven cash flows, a series of cash flow. Still we have a series, okay, means we have more than one payment, but where the amount varies from one period to the next period. So We have uneven cash flow. Uneven cash flow means the amount are different from one period to another period. Here is the example. You can see in annuity, we have just completed annuity. We have same amount, 100, 100, 100 and 100 each year. But here we have 100, then 300, 300, 300 and then 500. Means we have irregular cash flow. So for irregular cash flows, we cannot use the formula of annuity. So we can use simple present value that we have done the class before yesterday. We have two problems related to uneven cash flows, 5-18 and 5-20. So first we will complete 5-18. Find the present value. So present value is required of the following cash flow streams at 8% discount rate. So 8% is the interest rate. We have two different streams, or you can say we have two different alternative or two different projects. Time period is for 5 years, and the stream is there are two streams: A, 100, 400, 400, 400 and $300. Stream B include 300, 400, 400, 400 and $100. So we are going to solve it right now. Okay, class. Stream A. Okay, we have here from 0, 1, 2, 3, 4, 5. We have 5 years. Then cash flow, we have zero amount in year 0, then 100, 400, 400, $400, and the last year we have $300. Okay, so first of all we have to calculate the present value factor. And here is the formula to calculate present value factor. Okay, PVF is equal to, so in year 1 we have simply year 1 1 divide by 1 plus what was the interest rate? It was 8%. Okay, 1 plus 0.08, and n is 0. Okay, now you can see here, first year the n is 1, second year the n is 2, and third year the n is 3, fourth year n is 4, 5 year n is 5. So just calculate present value factor is equal to here 1, because this was the year 1. Here this is the present value factor for year 2, for year 3, for year 4, and the 5th year. Okay, now how you calculate present values? Simply by multiplying cash flows with, here it is, I can write the formula. Present value is equal to cash flow multiplied by present value factors. Okay, so we have D6 multiplied by D6. B6. So here are the values, and just add all these values. So 1200 is the total present value of stream A. The same method we are going to repeat for stream B. Okay, stream B. For stream B, we have $300 in year 1, 400, 400, and then 1 year. Okay, so you can see the total present value is $1,300. Now, which stream is better? Obviously, the stream which has more present value, or which has higher present value, is the best one. So stream B is the best stream, or it has greater present value. The last problem for today is 5-20. I'm just go through it. Here we have 10% rate. That is your, you can say, interest rate. We have 3 different contracts with 3 different amount, and present value is required. And what they have mentioned that as his advisor, which contract would you recommend that he accept, or whichever is the best, we are going to select it by calculating present value. So I'm just going to show you the answer. Here it is. Now you can see stream A, 4 years, and we have calculated present value factor, and in the last step we multiply present value factor with cash flow, and this is the total value of this is the total present value of stream A, 9.5 million. Stream B has 10.7 million, and stream C has $8.6 million. So which one is the best one? Obviously stream B. So the answer is stream B is the best one. Okay, class. So that's it for today's class.